Now, first point is partition values. It is the values of variable that divides the total frequency into number of equal parts, known as partition values. Median, quartiles, deciles, and percentiles are the partition values. Here we also discuss quartiles, deciles, and percentiles. First is the quartiles. Quartiles are those values of the variable which divide the total frequency into four equal parts. There will be three such points, Q1, Q2 and Q3, such that Q1 less equal Q2 less equal Q3 is 3 quartile. Q1 is known as the lower or first quartile, Q2 is known as the middle quartile, and Q3 is known as upper quartile or third quartile. So first, lower quartile, that is Q1, which is equal to L plus N by 4 minus CF divided by F into H. Next is the middle quartile, is equal to Q1 plus L plus 2N by 4 minus CF divided by F into H, which is also equal to median. Upper quartile, Q3, is equal to L plus 3N by 4 minus CF divided by F into H, where L is equal to lower limit of Qith class and N is equal to summation of Fi, where I running from 1 to N, and Cf is equal to cumulative frequency of the class preceding the Qith class, and F is equal to frequency of Qith class. H is equal to class interval of Qith class. Quartiles can be also be determined graphically by plotting the less than augure curve, and less than augure curve we discussed in last chapter. Next point is the deciles. Deciles are those values of variable that divide the total observation into 10 equal parts. Next, percentiles. Percentiles are those values of variable that divides the total observation into 100 equal parts. Next, box and whisker plot. The box and whisker plot was introduced by American scientist Johann Tuke in 1977. So procedure to draw a box plot. First step is arrange the data in ascending or descending order of magnitude. Next step, second step, is determine the 5 number summary, that is minimum observation, first quartile, second quartile, third quartile and maximum observation. Step 3, draw a box from the first quartile to the third quartile. Note that the length of the box will be Q3 to Q1, which is known as interquartile range. Step 4, a vertical line goes through the box at the median and the line go from lower quartile to the minimum and upper quartile to the maximum. So using example we plot using example box. Example is represent the following data using box plot technique. Number 16, 15, 28, 17, 24, 22, 27, 36, 34, 29 and 22. So first arrange the observation solution. First arrange the observation in ascending order of magnitude. So first number is 15, next is 16, 17, 22, 22, 24, 27, 28, 29, 34 and last is the 36. So here n is equal to 1 2 3 4 5 6 7 8 9 10 11, and which is odd. So first, lower quartile, which is equal to q1, which is equal to value of n plus 1 by 4th observation, which is equal to value of n is 11 plus 1 by 4th observation, which is equal to value of 11 plus 1 is 12, 12 by 4 is third observation. Third observation is 1 2 3 is 17. So q1 is equal to 17. Next is a q2. Then median is equal to q2, which is equal to value of n plus 1 by 2th observation, which is equal to value of n is 11 plus 1 by 2 observation. Value of 11 plus 1 is 12, 12 by 2 is 6th observation. So q2 is equal to 6th observation, 1 2 3 4 5 6 24, and last is the q3, which is equal to value of 3 n plus 1 by 4th observation. So value of here 3 into n is 11, 11 plus 1 is 12, 12 into 3 n is 11, 11 plus 1 is 12, 12 into 3 is 12. So 3 into 12 by 4th observation, which is value of 9th observation after solving, which is equal to 9th observation is 1 2 3 4 5 6 7. 9th observation is 27. So q3, q2 and q1. Also we draw box plot using the procedure. So first स्टेप म्हणजे फर्स्ट स्टेप झालेली आहे, सेकंड पण झाली आहे. आता आपल्याला काय करायचं आहे, फक्त बॉक्स प्लॉट करायचा आहे. त्याच्यासाठी फर्स्ट वी हॅव टू ड्रॉ अ लाईन. नंबर्स स्टार्ट फ्रॉम 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and last is 36. So first draw a box from first quartile to third quartile. So first quartile is 17 and third quartile is 27. Third quartile is 29. So from 17 to 30, 29. 17 to 29. Q1 and Q3. For next step, the vertical line goes through the box at the median. So median is 20, median is 24. So draw here a vertical line from 24, Q2, and in next step, the whiskers go from lower quartile to the minimum and upper quartile to the maximum. So lower quartile is 15. So draw here one line, and upper quartile is 36. So draw here also line. This is the whisker plot graph. Whisker plot. Example: the frequency distribution number of lectures attended by 500 students is given below. The first quartile of frequency distribution is 21.5. Find the values of the missing frequencies. Number of lecture attended: 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50. And number of students are 42, 24, dash 90, 122, dash 56, and 20 and 33. So we have to calculate missing frequency. Then we draw first we compute first less than cumulative frequency distribution table. So draw first frequency distribution table. First column is number of student attended by number of lectures attended by a student. Next column, number of students. Third column, LCF, that is least cumulative frequency. Then number of students: 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 45, 40 to 45, and 45 to 50. Number of students are 42. Here dash, so we use a 90, (122). Next dash, so B 56, 20, and 33. Then LCF means first frequency is as it is. For second, addition of these two, 24 plus A. Next, addition of these three, 24 plus 90 is 114 plus A. Next, 236 plus A, 236 plus A, 236 plus A plus B, 292 plus A plus B, 312 plus A plus B, 345 plus A plus B, plus A plus B. So for using lower quartile, we find A and B, these missing frequencies. In example, we have to given that first quartile Q1 is equal to 21.5 and capital N is equal to 500. Then first we find N by 4, that is N by 4, which is equal to 500 by 4, which is equal to 125. So next is the locate the qith class. That is, qith class means what? A class corresponding to which less than cumulative frequency is just greater than or equal to N by 4 for the first term is as qith class. So 125 is just greater than 114 plus A. So the Q1 class is 20 to 25. Q1 class is equal to 20 to 25, and L is equal to lower limit, that is 20, and CF cumulative frequency of the class preceding the QIth class. So QIth class is, this is quartile class, and QI class is 24 plus A. QI class is 114 plus A, and cumulative frequency is just preceding the cumulative frequency cumulative frequency of the class preceding the QI class, that is 24 plus A. Cumulative frequency is 24 plus A, and F is equal to frequency of QI class is frequency of QIth class, that is QIth class is this. So frequency of QIth class is 90. So F is equal to 90, and H is equal to class width, that is upper class minus lower class is 5, and capital N is equal to 500, which is equal to this 345 plus A plus B. So A plus B is equal to 155. So first quartile class, lower quartile Q1 is equal to L plus N by 4 minus CF divided by F into H. So Q1 is 21.5, L is 20 plus N by 4 is 125 minus CF is 24 plus A. 24 plus A divided by F is 90 into a height is 5, which is equal to 21.5 minus 20 is equal to subtraction 121 minus A divided by 90, 101 minus A 90 minus A upon 90 into 5. Therefore 21.5 minus 20 is 1.5. Multiply this 90 in this side into 90 upon this 5 is divided, which is equal to 101 minus A. Therefore this A is equal to 101, and after solving this we get minus 27. So A is equal to 74, and using A plus B is equal to 155. So A is 74 plus B is equal to 155. So B is equal to 81. 155 minus 74 is 81. So the missing frequencies are A is equal to 74 and B is equal to 81. Next point, dispersion. Dispersion is the measure of the variation of the items in the data. The value which measures this tendency of observations to differ from each other is called measures of dispersion. Request is of good measures of dispersion. First, it should be rigidly defined. It should be based on all the observation. Third, it should be easily calculated. Fourth, it should be responsive to further mathematical treatment. Fifth, it should be affected as little as possible by fluctuation of sampling. Next, absolute and relative measures of dispersion. The measures of dispersion which are expressed in terms of the original units of a series are termed as absolute measures. The measures of dispersion which are expressed in terms of the different units of a series are termed as relative measure. Next, Next point is range and coefficient of range. Range. It is the difference between the greatest and the smallest observation of the distribution. So range is equal to L minus S, and coefficient of range is equal to L minus S upon L plus S. So example, 5 people play golf and at one hole their scores are 3, 4, 4, 5 and 7. For these scores, find range and coefficient of range. Firstly, we find smallest observation and greatest observation. So greatest observation is equal to 7 and smallest observation is equal to 3. Greatest observation is so largest observation and smallest. Range is equal to L minus S, which is equal to 7 minus 3, which is equal to 4, and coefficient of range is equal to L minus S upon L plus S, which is equal to 7 minus 3 by 7 plus 3, which is equal to 7 minus 3 is 4 and 7 plus 3 is 10, which is equal to 0.4. Last point is quartile deviation or semi-interquartile range. The difference between the upper and lower quartiles, that is Q3 minus Q1, is known as interquartile range. Half of this difference is called as semi-quartile range. So quartile deviation is equal to Q3 minus Q1 upon 2, and coefficient of quartile deviation is equal to Q3 minus Q1 upon Q3 plus Q1. Using this formula, we find quartile deviation and coefficient of quartile deviation.